Alright, so as we were saying, so I'm going to just draw the diagram back. So here we have 1/30, and here we have the 0-minute interval, which is 7 o'clock. Here we have, let me draw it bigger, sorry. It has to be bigger so that we don't have issues understanding the diagram. Let me just draw it bigger. Alright, so here we have 1/30. Sorry. Here we have, ignore that line, I cannot be cancelling all the time. So here we have 1/30, and here we are having our 7:30, because that's the last time that the bus is going to come. Say between 7 and 7:30. Here we have 7 o'clock, and in the middle here we have 7:15. So now the question is asking us that we should find the probability that the passenger waits more than 5 minutes, right? So when will he arrive that he's going to wait more than 5 minutes? Now, if he arrives between 7 o'clock and 7:10, he's going to wait more than 5 minutes, right? Because if he arrives 7:10, he only has to wait 5 minutes for the bus to arrive. But if he arrives between 7 o'clock and 7:10, he's going to wait more than 5 minutes. Because if he arrives 7:09, he will wait 6 minutes, which is more than 5. If he arrives 7:08, he's going to wait 7 minutes, which is more than 5. So that means the probability that he's going to arrive, that he's going to wait more than 5 minutes, is between, if he arrives between 7 and 7:10. But now, if he comes after 7:15, you know that the bus comes 7 o'clock, and he comes 7:15 and 7:30. But now, if he does not arrive between 7 o'clock and 7:15, and the bus has gone, if he now comes and he arrives between 7:15 and 7:25, he's still going to wait more than 5 minutes, right? If he arrives between 7:15 and 7:25, he's going to wait more than 5 minutes. So if he arrives between this time and between this time, he is going to wait more than 5. So it's either if he arrives this time or if he arrives within this time. And we know that the or indicator is what? Positive. So that's why it's very important that the knowledge of probability is very important, actually. So now we are going to draw this, right? We're going to find the area. The area is going to give us the probability. So we are going to find the area. So I'm going to draw this, and I'm going to shade this side. Sorry. So this is area we're looking for. We're looking for these two areas. So it's either he arrives here or he arrives here. So now the time interval here, this is 7:10. The time interval here is 10 minutes. And the time interval here is also 10 minutes. So that means the probability that he waits more than 5 minutes is going to be the probability that he arrives between 7:10 and 7 o'clock, 7 o'clock and 7:10, or the probability that he arrives between 7:15 and 7:25. So now for uniform continuous distribution, we're going to use the area. We're going to find using the area to solve this question, right? So now the area is base times height, basically. So our base, which is here, is 10 times our height, which is what? 1/30, plus our base for 7:15 to 7:25, which is also what? 10 times 1/30. So this is going to give us 1/3 plus 1/3, and our probability that the passenger waits more than 5 minutes for a bus is 2/3. Now I know that this might be looking to be a little too much for you to process at a go, but I want you just, if you're having issues, watch the video again, and I believe you will get it. Let's solve question 2. Okay, let me use this space because I don't want to make another video for this particular question. So now find the probability that the passenger waits more than 10 minutes for a bus, right? So what we're just going to do is we're going to find, this is 7:15, here is 7:30, this is our graph, and here is 7 o'clock. So we're going to find at which time will he arrive that is going to wait for more than 10 minutes. If he arrives between 7 o'clock and 7:05, he's going to wait more than 10 minutes, because the difference between 10:15 and 10:05 is 10 minutes, right? And if he arrives between 7:15 and 7:20, the difference between 7:20 and 7:30 is 10 minutes. Here is 5 minutes, here is 5 minutes, right? But now look at it. How do we know that if he arrives between 7 o'clock and 7:05, he is going to wait for more than 10 minutes? It's very simple. If he arrives 7:01, he's going to wait for 14 minutes. So it is more than 10. If he arrives 7:02, he's going to wait for 13 minutes. It is more than 10. So that's how you know that it is more than 10, right? So it's either he arrives between this time or he arrives between this time, right? Because this, at this point, the bus has already come and he has gone. The bus arrives here, and arrives here. 7:30 is the end of the distribution. If you have like 7:45, and they will now look for 7:30 and 7:35. But this is the end of the distribution, right? So now for this one, we have the probability that X, he arrives for more than 10 minutes. So it's going to be the area of this place or the area of this place. So we have the interval between 7 o'clock and 7:05 is 5 times 1/30 plus our base for this side is 5 times 1/30. So this is going to give us 1/6 plus 1/6, which is 2/6, which is 1/3, which is 0.33. So the probability that the passenger will wait more than 10 minutes is 0.33. This is for continuous uniform distribution.